Okay, let's dive into something that definitely trips a lot of people up, especially if you're looking at tech careers.
Hmm.
It's that classic question, computer science versus software engineering.
Yeah.
What's the actual difference?
Right. And, it's understandable why it's confusing for most people, maybe even some inside the field. They sound like they're pretty much the same thing.
Exactly. If you picture someone in either role, what pops into your head?
Probably someone sitting at a computer typing away, right?
Coding.
Yeah, just coding. And our brains kind of take a shortcut there, don't they?
They do. It's that representativeness heuristic we talked about. You see the surface similarity, a coding stereotype, and you think, okay, same field.
But that misses the core of what each one is actually about.
Totally. Think about it like this. One of the sources used a great analogy. Is studying literature the same thing as like being an author?
Hmm, good point.
Yeah.
Or studying statistics versus being a data scientist.
Exactly. There's obviously huge overlap. You need the stats to be the data scientist.
Right. But the day-to-day work, the focus, the ultimate goal, it's different.
That really helps clarify it. You see the tool, the code, the stats, but not necessarily the underlying science or the specific application.
Yeah.
So, our mission here, looking at all this material you've gathered, is to really peel back those layers.
Let's do it.
We want to unpack what computer science, really is, what software engineering actually involves, how they're different, where they overlap.
And the career paths, right. What
Okay.
jobs can you actually get?
Yes, exactly. And crucially, what else besides just the degree might you need? Because the sources suggest it's not just about the diploma anymore.
That's a big one.
So all based on the material here, hopefully helping you make a more informed choice.
Okay, so let's start with the basics. Defining them based on these sources, computer science or CS.
Yeah, what is fundamentally?
It's really the study of computers and computational systems themselves. It's heavy on the theoretical foundations,
So like the science behind it all.
pretty much. Understanding how computers work deep down, how to use computational thinking to solve problems, and, how to create software, but from a more scientific viewpoint.
Okay. The sources mention things like data structures, algorithms, theory of computation, cryptography, AI, machine learning.
Right. All those core areas,
Yeah.
cybersecurity, databases, it's broad and foundational.
The emphasis seems to be on problem solving, innovation, maybe creating new ways of computing.
Yeah, or advancing the existing ones. It gets into the science of how hardware and software interact.
Got it. So if CS is the underlying science, where does software engineering, or SE, fit into this picture? The sources say it's technically a branch of CS.
And that's key. It's not totally separate. SE takes those CS principles, the knowledge, and applies specific engineering methods to actually build software.
Ah, so applying engineering discipline to the process.
Exactly. It's about a systematic way to design software, build it, test it, evaluate it, maintain it, manage the whole life cycle.
So CS gives you the scientific building blocks, maybe the really optimized algorithms.
Mm-hmm.
And SE gives you the blueprint and the process to construct a reliable building using those blocks.
That's a good way to put it. SE is highly practical. The goal is usually building large-scale, high-quality software that works reliably and meets what the user or the business actually needs.
Okay.
So while CS might dig into the hardware-software science, SE is mostly focused just on the software itself, creating it, structuring it, keeping it running.
That distinction feels really important, the science behind versus the engineering to build. Let's dig into those differences a bit more, because that's where the choice gets clearer, right?
Absolutely. The sources break it down nicely. First, think about the degree focus.
Okay.
CS degrees, like we said, lean theoretical. Computational theory, algorithms, the math behind it all, innovation.
Right.
An SE degree is practical from the get-go, applying engineering principles, focusing on software design, system architecture, project management methods, quality, reliability.
So one source said CS learns the science behind, SE applies it to product building.
Yeah, that captures it well. And that difference shapes the curriculum, naturally.
Makes sense. What does that look like?
Well, in CS, you'll probably find more advanced theory, abstract math, maybe deeper dives into AI concepts, cybersecurity principles, lower-level systems stuff.
Okay.
SE courses focus more on the how-to of building software well. Things like software design patterns, architectural choices, robust testing, debugging techniques, the whole software development lifecycle, the SDLC.
Which is like the structured process for building software?
Exactly. Planning, coding, testing, deployment, maintenance, plus project management, teamwork, stuff you need on a real dev team.
So both might study algorithms, but maybe the SE student is focused on efficiently implementing algorithm X in a huge system,
Right.
while the CS student might be trying to prove how fast algorithm X can be, or maybe inventing algorithm Y.
That gets at the core difference described in the sources. And it plays out in the software design process, too. A computer scientist might analyze the theory to figure out the absolute best theoretical way to solve a problem computationally.
Okay, the ideal solution in theory.
Yeah. Then the software engineer takes that understanding, considers the real-world constraints, budget, time, user needs, and designs the practical framework and architecture to actually build the program.
So CS is like designing the perfect engine components, and SE is figuring out how to assemble them into a reliable car that people can actually drive.
That works. It connects to this idea of engineering versus scientific theories.
Right.
CS develops the scientific theories about computing. SE uses those theories as tools within an engineering process. It applies real-world engineering ideas, reliability, scalability, maintainability, cost directly.
Whereas CS might study related math or engineering concepts, but maybe more abstractly.
Often, yes, as part of the theoretical grounding.
And what about the final product itself? How do their focuses differ there?
The sources suggest CS might be more focused on the internal complexity, the algorithms, the data analytics inside the program.
Okay, the cleverness under the hood.
While SE is concerned with the whole process of delivering a working product, the design, the build, the testing, like quality assurance or QA, making sure it meets quality standards and actually works for the user.
So CS optimizes the engine's performance. SE builds the whole car and makes sure it passes inspection and is easy to drive.
Good analogy again. And then there's coding. This is the big confusion point.
Because both do it. A lot.
A lot. But the purpose can differ. In SE, coding is primarily the tool for developing and building the actual software product according to the design.
Following the blueprint.
Right. In CS, coding might be used more to explore a theory, implement an algorithm to test it, study programming languages themselves, or figure out hardware-software compatibility issues.
Okay, that adds a lot more nuance than just saying they both code. You see why they're coding.
Exactly. But, and this is really important, the sources also stress the similarities and overlap. They aren't totally separate worlds.
Right. You can't build the engineered product without understanding the science.
Absolutely. Both degrees give you a solid grounding in computer architecture, software systems fundamentals.
And students in both are definitely getting hands-on coding experience, learning common languages, Java, Python, C++, SQL, JavaScript.
Yep. And often, especially in the first year or two, a lot of the courses actually overlap. You might be sitting next to CS majors in your SE algorithms class, or vice versa.
Which leads to maybe the biggest point for someone choosing. Graduates from either degree can often get the same jobs.
That's a huge takeaway from the sources. Very frequently, they end up in similar roles.
Okay, so if the jobs can be the same, how much does the degree choice really matter? Let's talk career paths.
Well, the most common path for both, according to the material, is ending up as a software developer or a software engineer.
Makes sense.
One person in the RIT discussion mentioned that most CS grads who don't go for a PhD basically become software engineers anyway.
Interesting. But are there specific roles where one degree might give you, like, an edge?
The sources suggest maybe, yeah. CS could potentially set you up better for roles that are more theoretical, research-focused, or maybe highly specialized.
Like what?
Think data scientist, maybe a cybersecurity analyst dealing with threat modeling, a systems architect designing really complex infrastructures, AML specialist, R&D roles.
Okay. Embedded systems? Game engines, maybe?
Potentially, yeah. Things that require a really deep theoretical understanding.
And for software engineering grads?
The roles often line up more directly with the build, test, and maintain cycle.
Yeah.
QA engineers, mobile app developers, database administrators.
Project management? Team lead roles?
Definitely. Solutions architecture, DevOps, which is that blend of development and operations, maybe the game design or application side, rather than the core engine tech.
So maybe there's like a 90% overlap for general software dev roles,
Right.
but then a 10% difference where one degree is favored for certain specialization.
That seems like a fair reading of the consensus in the sources. And the job outlook and salaries. Both look really strong.
Yeah, the numbers cited were pretty impressive. BLS data predicting much faster than average growth.
Like 17% for developers QA,
Yeah.
and even higher, 27% for research scientists through 2033.
And the pay reflects that demand. Median salaries well into six figures.
For sure, high demand in both areas. One source did suggest that maybe SE has slightly more immediate job openings right now because every industry, finance, healthcare, retail, needs practical software built and maintained.
While CS might open doors to broader, maybe more cutting-edge fields like AI or research, but perhaps fewer roles overall compared to general development.
That could be one interpretation.
Yeah.
It's also interesting how the sources handle AI.
Right, the idea that AI might automate coding.
Yeah, but they argue it actually increases the need for skilled people who can manage these complex AI-driven systems, so the demand isn't shrinking.
Good point. The nature of the work might change, but the need for smart people remains.
Definitely. The need to design, build, and manage software isn't going anywhere. But, and this is a really critical point hammered home in the sources, it's about what happens beyond the degree, why college alone isn't enough.
Ah, yes, the college preparation fallacy, the old idea that the degree is your golden ticket.
Exactly. And the sources are pretty blunt. That view is outdated, especially in tech.
So just having the CS or SE diploma, it's not the whole story.
Far from it, according to this material. It's often not enough on its own to really stand out and land those top-tier, high-paying software jobs.
So the degree is necessary but not sufficient. What's missing?
Experience. Real-world practical experience
Yeah.
gained while you're studying, ideally. This comes up again and again.
You mean like internships and co-ops?
Described as maybe the single most important thing. Spending months actually working as an engineer in a company.
And it's not just for the resume line item.
No, it's about learning the stuff they don't teach you in class, like using Git for version control properly on a team, working on a massive existing code base, navigating team dynamics, using industry-standard tools.
Things you only learn by doing.
Precisely. And critically, internships often lead directly to full-time job offers after graduation. It's a major pipeline.
Okay, so internships are huge. What else? What if you can't land one right away?
Hackathons and personal projects are highlighted as super valuable, maybe even underestimated.
How so?
Building things. Especially in a team at a hackathon, you learn new tech quickly. The sources mention things like Docker or specific databases. You build a portfolio.
It shows you can actually create something.
Exactly. It demonstrates initiative and practical skill. One person on Reddit even said their experience in game modding communities was arguably more valuable for getting certain jobs than their actual major.
Wow, so side projects can really matter. Some even suggest starting before college.
Yeah, to get ahead of the curve. It really changes the perspective from just passively receiving knowledge in lectures.
To actively building and demonstrating skills.
That's the key. And research was mentioned too. Maybe more for academia-bound folks, but still, good experience, good for the resume if internships are tough to get.
It shows problem-solving skills.
Right. The big message is, the industry moves fast, faster than curricula can always keep up. You have to be proactive in learning and building. One source even said SE programs sometimes aim to teach students how to learn on their own because they'll need that skill constantly.
That ability to self-teach and adapt. Yeah, that sounds essential in tech.
Absolutely fundamental.
Okay, so let's tie this all together for you, the listener. We've got the differences, the similarities, the careers, this crucial need for experience. How do you actually choose your path between CS and SE?
Well, distilling the advice from the sources, it really boils down to knowing yourself. What genuinely interests you? What do you enjoy doing?
Are you drawn more to the why? The theory, the math, the fundamental problems, how computation works, maybe inventing new algorithms or approaches?
If yes, then the foundational depth of computer science might be a better fit.
Or are you more excited by the how? The practical challenge of building robust, large-scale systems, taking user needs and turning them into working software, managing the process, ensuring quality.
Then the engineering focus of software engineering probably aligns better with your interests.
You need to think about what kind of classes, what kind of problems you'd actually enjoy tackling day after day for 4 or 5 years.
What gets you excited? Solving deep theoretical puzzles or solving practical construction challenges?
And it's worth repeating. The sources agree that neither choice is inherently wrong. Both are strong degrees, both lead to great careers.
Definitely. If you're really unsure, some sources hinted that CS might be a slightly broader starting point. It gives you that theoretical base, opens doors to AI, cyber, research.
Yeah.
But you can still easily go into software engineering roles from CS.
But the giant asterisk on all of this, the thing that applies whichever path you choose,
Is the practical experience. Internships, co-ops, projects, hackathons.
Without proof you can apply your knowledge and build things using real-world tools, the degree alone often isn't enough to compete effectively.
That experience is what bridges the gap between the classroom and what employers are looking for.
Okay, so to wrap up, computer science is diving deep into the science, the theory, the why of computation and innovation. Software engineering is focused on applying solid engineering principles to build and maintain reliable software for practical use.
Both great paths, both with bright futures.
But success, especially landing those really desirable jobs, seems to hinge heavily on getting that hands-on practical experience to complement your formal education.
Which leads us to a final thought for you to chew on.
Yeah.
Given how much the sources stress this real-world experience, even calling the degree guarantees job idea a fallacy,
Yeah.
how does that change the way you might think about planning your education or career? Does it maybe challenge that traditional view of college as the only thing that matters and instead push you towards a more active, experience-driven approach as the real key to making it in the tech world today?